Hello children, this is Edison. In this video, we are going to discuss about the chapter Integrals part 8. In this part, we'll be discussing the properties of the definite integrals. Before we enter into the properties of definite integral, we do few sums on definite integrals. Okay, yeah. The first question in this integral 0 to pi by 4 sine 2x dx. Children, we did the indefinite integral. Same thing we have to do. Children, this is what the rule actually. A to b f of x dx is nothing but capital F of x. A to b is nothing but f of b minus f of a. That's all. So now what we have to do? We have to do the integration. So the integration of sine 2x is nothing but 1 by 2 into minus actually cos 2x. Now apply the limit 0 to pi by 4. That's all. Okay. So now you can put minus 1 by 2 out. We can substitute that upper limit cos of 2 into pi by 4 minus cos of 2 bracket 0. That's all. Okay. Now it is minus 1 by 2 into cos pi by 2 minus cos 0. Okay. We know that cos pi by 2 is 0, but cos 0 is 1. So here it is 1 by 2 is the answer. That's all, children. So how easily we are producing the answer? Okay, this rule only. Okay, yes. I do one more sum on this. Integral 2 to 3 dx by x square minus. So here we need to remember the formula. Integral dx by x square minus a square is nothing but 1 by 2a log of x minus a by x plus a plus c. This formula we remember, children. In that way we can write this as 1 by 2 into 1, because here a is nothing but 1. Okay, log of this x minus 1 by x plus 1, 2, 3. This 1 by 2 is out. Now log of this 3 minus 1 by 3 plus 1 minus log of 2 minus 1 by 2 plus 1. Okay, yes, that's all, children. So 1 by 2 into, now log of it is 2 by 4 minus log of it is 1 by 3. Children, we know the rule, no? You know what is the rule? Log a minus log b. Log a minus log b is nothing but a log of a by b. You can apply that, children. That means 1 by 2 into log of 2 by 4 divided by 1 by 3. So here it is 1 by 2 into log of 2 by 4, it is 1 by 2, 1 by 2 into 3 by 1. So finally we can give the answer is 1 by 2 into log 3 by 2, or else we can write 1 by 2 into log 3 minus log 2. That's all, children. When they give the definite integration, what we have to do, children? We have to apply as usual what we did in the indefinite integration. We do the integration and get the answer. In that we have to give the limit. Upper limit should be substituted first, minus, then lower limit should be substituted. That's all, children. So like this way only you should supposed to. Now using the substitution method, we do one more sum. Integral 0 to 1 tan inverse of x by 1 plus x square dx. See, children, so directly we cannot do this also. So what we will do? We will do the substitution. Let t equal to tan inverse of x. Now we will find dt equal to 1 by 1 plus x square dx. We can substitute 1 by 1 plus x square is nothing but it is dt. But at the same time, the limit also in terms of x only, that also should be converted x and t. Now when x is 0 and x is 1, what will you get? You know what is t? T is tan inverse of x. Suppose t equal to tan inverse of 0. So that means it is tan inverse of 0, 0. The next, tan inverse of 1. When will you get 1? When angle is 45 degrees. That means pi by 4. So we will be writing it is pi by 4. That's all, children. Okay, now we can write. So this has what? Integral, instead of 0 we'll write 0 only, but here pi by 4. Limit also changed, children. So now t into actually dt, because 1 by 1 plus x square dx is dt. We can replace. That's all. We now do the integration for t. It is t square by 2. Now apply the limit 0 to pi by 4. It is nothing but pi by 4 whole square into 1 by 2. So 1 by 2 into pi square by 16. Your answer is pi square by 32. This is the required answer, children. Okay, yes. So I do one more sum. Integral 0 to pi by 2 root of sine phi into cos power phi d. So now see, children, I'm just going to rewrite what it is. This 0 to pi by 2 root of sine phi. Here it is cos power 4 phi into cos phi d phi. So here this cos power 4, I can write it as a again sine. So that means integral 0 to pi by 2 root of sine phi. This actually cos power 4 is nothing but cos square phi whole square. So that means we can write this as 1 minus sine square phi whole square, but here is cos square itself, cos phi itself. Children, here what we are having? We have sine. So let t equal to sine phi. Therefore your dt is nothing but cos phi d phi only. So now we can replace, but this has to be replaced. The t also should be, so the limit also should be changed. That means x t, x 0 pi by 2. Now see, sine 0 is nothing but 0. Sine pi by 2, it is nothing but 1. We changed, so it becomes 0 to 1 root of t bracket 1 minus t square whole square. Okay, yes, into dt, because cos phi d phi is nothing but dt. That's all, children. So now you can expand and multiply inside. This means 0 to 1, it is root t. No, I can write t power 1 by 2. You can expand this 1 minus 2t square plus t power 4 dt. Okay, this can be multiplied inside. Integral 0 to 1, it is t power 1 by 2 minus 2 t power 5 by 2, because 1 by 2 plus 2 is 5 by 2 then t power 9 by 2 dt. Okay, so now we can do the integration on this. It is t power 1 by 2. Now root t is, we can say it is 2 by 3 t power 3 by 2 minus, it is 2 into t power 5 by 2 plus 1 by 5 by 2 plus 1. So 5 by 2 plus 1 means what will you get? It is 7 by 2. So that means 2 by 7 t power 7 by 2 plus 9 means it is plus 1, 11 by 2. So therefore 2 by 11 into t power 11 by 2. That's all, children. Okay, but we can apply the limit 0 and 1. So that means it is 2 by 3, this is 1, minus 4 by 7, this also 1, plus 2 by 11, this also 1, then minus 0 only. Okay, we get. So 54 by 231 is the answer, children. Now we come to the properties of integral. Why the properties of integrals needed? Children, do you remember in determinants we did the properties of the determinants? You know why? Because to make it easier, if you use a property, the determinant we can find easily. Like that only, children. Here also we did some sums. Some actually what may be easier, some questions may be difficult for us. But if you use the property, if the sum comes under property, means you can give the answer immediately as the next step itself, children. So the properties of integral is very much necessary. The first property, dummy variable property. So that means integral a to b f of x dx is nothing but integral a to b f of y dy. This is what does it mean? Only the variable is changing, function remains same only. So if I consider f of x is equal to x square, okay, f of y is equal to what? Y square only. That is what here. So but you are differentiating with integrating with respect to x, here integrating with respect to y only. So you'll be getting same answer for that only. Okay, children? Yes. So For example, integral 1 to 2 x square dx. What will I get? X cube by 3, 1 to 2, it is 8 by 3 minus 1 by 3, it is 7 by 3. Okay, well, now if I apply integral 1 to 2 y square dy, same function, only the variable is changing. Now what will I do? Same way, y cube by 3, so then it is 1 to 2, then same way 2 cube by 3, 8 by 3 minus 1 by 3, it is 7 by 3. See children, I am getting same answer, that's all. So this is the first property. Now we come to the second. Integral a to b f of x dx is nothing but minus integral b to a f of x dx. What do you understand from this? Actually, what if you interchange the limit, the sign will change. Obviously children, you see here integral a to b f of x dx is nothing but, what are we writing? F of x, here a to b, then f of b minus f of a, correct? Huh? Yeah. Now see here integral b to a f of x dx. What I am doing? F of x, it is b to a. Therefore we are writing f of b f of a minus f of b. See children, this actually if you take minus out, f of b minus f of a. So this is nothing but minus integral a to b f of x dx. That's all children. If you interchange the limit, you get the integration sign changed. That's all children. Only sign change. The magnitude remains same. Number won't change at all. Okay? Yeah. The next property. Integral a to b f of x dx is nothing but integral a to c f of x dx plus integral c to b f of x dx. That's all. This is telling in this way. That means what? We can, in between a and b, you can choose any number as the middle limit. Okay, in between one limit, then you can split into two integral form, two integral. Okay, we can divide into 3 also, 4 also, 5 also children. Okay, if I write this integral 1 to 3 f of x dx is nothing but, I can write integral 1 to 2 f of x dx plus integral 2 to 3 f of x dx. Like this I can write. So it depends children. Even you can write a 1 to 1.5, then 1.5 to 2, 2 to 2.5, 2.5 to 3, up to 3. Beginning is 1, the ending is 3 only. That won't change. Okay, like this we can write. You can give an example also. Simple example I am taking. Integral 1 to 3 x dx. Okay, now see that integral 1 to 2 x dx plus integral 2 to 3 x dx. See children, both the side I am finding, you will get the same answer only. Now here x square by 2, here 1 to 3, here x square by 2, here 1 to 2, plus x square by 2, 2 to 3, apply. It is 3 square, 9 by 2 minus 1 by 2 you get. Here it is 2 square, 4 by 2 minus 1 by 2, plus here 3 square, 9 by 2 minus 2 square, 4 by 2. See children, this 4 by 2 will get cancelled. 9 by 2 minus 1 by 2, 9 by 2 minus 1 by 2. I am getting it is 8 by 2. Here also it is 8 by 2. 4 equal to 4. See children, we are getting same answer. I just split it into 2. You can split into 3, 4, 5, etc. children. Okay, but you cannot exceed the n limit, upper limit. You cannot exceed the upper limit. Okay, this is the third property children. Fourth one. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. This is another one. Okay, so if they give the left hand side, this can be written in the right hand side form. You will be getting same answer only children. Really you will be getting same answer. If I choose integral 1 to 3 x dx, I am choosing the simple one for our better understanding. It can be written as 1 plus 3 minus x dx. Okay, that's all. So now here what will happen? Integral 1 to 3 x dx. Here integral 1 to 3, 1 plus 3, what? 4 minus x dx. You will be getting the same answer, children. It won't change at all. Now see, x square by 2. Here 1, 2, 3. Here 4x minus x square by 2. This also same limit 1, 2, 3 only. No change at all. Okay. Now it's actually what? 9 by 2 minus 1 by 2, because 9 3 square 9 equal to here what? 4 3s are 12 minus 9 by 2 minus 4 into 1 4 minus 1 by 2. Okay. Yeah. See children, it is nothing but left hand side 8 by 2 only. No change. But here see what? 12 minus 9 by 2 minus 4 plus 1 by 2. Okay. 12 minus 4 what? 8. Here what? Minus 8 by 2. Children, this is 4. So 4 equal to, here also what? 4 only. When you cancel, you will get 4. 8 minus 4, 4. See children, the calculation may vary, but we are getting the same answer. So integral a to b f of x dx is nothing but integral a to b f of a plus b minus x dx. So it will not change at all. So we can apply this idea also. Next, fifth property. From the fourth, we write this 0 to a f of x dx is nothing but integral same 0 to a f of a minus x dx. That's all children. Okay, this is actually from the fourth only. Yes, same idea children. Actually here 0 plus a minus x. 0 plus a minus x only. Okay, this is a particular case, but this is important one. We will be applying more sums in more sums. Okay, yes. Next, sixth one, integral 0 to 2a f of x dx is nothing but integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Okay, this is some particular case children. Okay, yes. So if they are giving integration 0 to 2a, so now we take the half of it. Okay, that means a 0 to a f of x plus 0 to a f of 2a minus x. Okay, this will happen for mostly in the trigonometric cases children. So if they give the question integral 0 to pi, okay, then sin x dx. So now what I am going to get split as what? Integral 0 to pi by 2, because of pi by 2. Yes, that means it is sin x only dx plus integral 0 to pi by 2 sin, what are 2a here? Pi, no, so pi minus x dx. That's all children. So sin x means minus cos x, so 0 to pi. Here also what? It is sin x, so minus cos x 0 to pi by 2 plus, children, we need to remember one rule. It is sin pi minus theta, it is sin theta only, so its differentiation now sin x same way minus cos x 0 to pi by 2 only. Okay children, that's all. So therefore it is minus out cos pi minus cos 0. Here in both the case we can see minus, you can take that out. It is cos pi by 2 minus cos 0, okay, plus cos pi by 2 minus cos 0. Children, actually I did some extra step in this, because these both are same. No, you can add them 2 times also we can write, since we are getting the same, but I did directly. Cos pi is minus 1, cos 0 is 1, so already minus there. Then here what children? Minus of cos pi by 2 0, but cos 0 1 plus cos pi by 2 0, cos 0 1. So now it is minus 2 into minus plus 2. Here minus 2 into, so it is 2. Children, this both are equal. You see that integral 0 to 2a f of x dx, 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Okay, wherever it is necessary we can apply this rule. Okay children. Yeah. Next, seventh property, integral 0 to 2a f of x dx is equal to, here we have two cases children. One is 2 times integral 0 to a f of x dx. Another one is 0. See children, this 2 times 0 to a f of x will happen if f of 2a minus x is equal to f of x itself. This will happen now if f of 2a minus x is equal to minus f of x. Okay, this is what, children. If f of 2a minus x is minus f of x, means the integration answer is 0. If f of 2a minus x is f of x, means 2 times integral 0 to a f of x dx. Okay, children? Yes, so it's like for the previous one, it is integral 0 to pi sin x. No, so if I apply sin pi minus x, sin x itself I am getting f of 2a minus x, f of x itself. So I am getting same thing only. Okay, so for the first case we can give the previous example. For the second case, you see what I am going to give. So in this first case, I can choose integral 0 to pi sin x dx. So here 2a is nothing but x pi. Okay, now f of x is nothing but sin x. I'll apply f of 2a minus x, that means f of pi minus x, that is sin of pi minus x. Children, I am getting sin x itself. It is nothing but f of x. So see here, this happens. So therefore we can say integral 0 to 2a f of x dx as integral 0 to a 2 times f of x dx, and then we can do the integration. We can apply, doesn't matter. But you see the another example, integral 0 to pi cos x dx, 0 to pi cos x dx. Now see, children, what I am going to say. I am going to say f of x is cos x. Okay, then a is 2a is equal to pi over here. Now I am going to apply, it is 2a minus x, that means f of pi minus x. What it is? Cos of pi minus x. It is minus cos x, is nothing but minus f of x. Children, I am getting this. So now my answer, you know what it is? Immediately I can write integral 0 to 2a f of x dx is equal to 0. Reason enna? Reason is if f of 2a minus x is minus f of x. So for this type of sum, by seeing itself we can give the answer. If f of the upper limit minus x is negative of it, means we can say it is 0. Integral 0 to pi cos x dx is nothing but 0. Okay, children? Yes, there are many examples. You can see the textbook. Now next property, integral minus a to a f of x dx. Here also we have the two category, children. One is 2 times integral 0 to a f of x dx. Second thing, it is 0. Here you know when it is f of minus a plus a 0 only, no? So f of minus x is equal to f of x. Here f of minus x is equal to minus f of x. Here, children, we need to remember, mind, f of minus x equal to f of x means it is even function. F of minus x equal to minus f of x means that is odd function. So if you find the given function is even odd, to check that one, it's very simple, just to substitute or replace minus x in the place of x. If we get the same function but negative of the given function, means it's very simple, we can say it is odd. If you are getting the same function after you substitute minus x also, that is even function. If it is even, 2 times the given integral, no, 0 to a. Yes, if it is odd function, your answer immediately 0, children. We shall take one example, children. Integral minus 1 to 1 x square dx. I just take f of x is nothing but x square itself. I apply f of minus x whole square is nothing but x square only, no, it's nothing but f of x. So it is even function. This implies even function. So what will I do, children? Immediately I will write integral minus 1 to 1 x square dx is 2 times integral 0 to 1 f of x dx. 2 times integral 0 to 1 x square dx, and then I can get, children, I am giving the simple example for your understanding. Okay, there are many questions you can do easily. Okay, if you use these properties, immediately you can get the answer, children. Okay, yeah. Now next I give for odd function. So it is similar way, it is minus 1 to 1 x cube dx. I can get the answer immediately 0, children. But see how it is. I take f of x is equal to x cube. Then f of minus x I am checking. So children, why I am using minus 1? Because upper limit and lower limit both are same sign, same number, but different sign. If it happens like that only, we can apply this idea. So minus x whole cube equal to what? Minus x cube is nothing but what? Minus f of x. Therefore, we can say it is odd function. My answer immediately minus 1 to 1 x cube dx is 0. Immediately we can write, children, if it is odd. Okay, yes. So these are all the properties we should suppose remember forever. Okay, children, to make the given integration more easier. So we do few example on this, children. Integral 0 to pi by 2 sine power 4 x by sine power 4x plus cos power 4x dx. Children, when you look at this sum, what will we think? Oh, you sine power 4 by sine power 4 plus cos power 4, what to do? Like that we may be thinking. Children, we need to remember on the simple rule. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. We have seen already. Okay, using this property, children, we are going to rewrite. I first name this as I. Same I can be rewritten as, this is nothing but 1. See, children, 0 to pi by 2. Now sine power 4 pi by 2 minus x by cos power 4, sine power 4 pi by 2 minus x plus cos power 4 pi by 2 minus x dx. Now see, it becomes 0 to pi by 2 sin pi by 2 minus theta cos theta. So therefore cos power 4 pi by 2 cos power 4x by here also cos power 4x plus sin power 4x, because cos 90 minus theta sin theta. Children, please do remember sin pi by 2 minus theta is cos theta, cos pi by 2 minus theta is sin theta. In that way, now I got another I in this way. Now compare 1 and 2, children. Both denominator same, integral same, the element also same, only the numerator is varying. You can add them 1 plus 2. Okay, put 1 plus 2. That means I plus I 2i equal to integral 0 to pi by 2. So it becomes sin power 4x plus cos power 4x by sin power 4x plus cos power 4x dx. Children, this get cancelled. This both get cancelled. So now what will I get? I will be getting integral 0 to pi by 2 only dx. It is nothing but x. So you can apply the limit 0 to pi by 2. Here is 2i. Therefore I is nothing but, children, here you will be getting only pi by 2. So this 2 will come down. Once 1 by 2, it is pi by 4 is your answer. See, that much bigger sum. Integral 0 to pi by 2 sin power 4x plus sin power 4x plus cos power 4x dx is nothing but pi by 4, children. How easier it is. Okay, so think easy. Really it will be more easier for you, children. Okay, so we do one more sum on this. Integral 0 to pi x dx by 1 plus sin. For this sum we use the same idea, children. Integral 0 to a f of x dx is nothing but integral 0 to a f of a minus x dx. Okay, so now first this I name this as I. This is 1. Now same I can be rewritten as integral 0 to pi, it is pi minus x by 1 plus sine of pi minus x dx. So now this written as 0 to pi minus x by 1 plus sin x itself. Why? Because sin pi minus theta sin theta itself. That is why. Now next, now see, children, this actually what considered as the second one. Same limit same denominator, same element, so we can add them. So therefore 1 plus 2, it is 2I is nothing but 0 to pi x plus pi minus x by 1 plus sin x dx. Now this x gets cancelled. Now what are we getting? Integral 0 to pi by 1 plus sin x dx. This is nothing but 2I. Okay children, so after I wrote this one, now see, this pi will be out, or else I can be written as pi by 2 integral 0 to pi 1 by 1 plus sin x dx. So here what I am going to do is pi by 2 integral 0 to pi, I multiply and divide by 1 minus sin x. Okay, so 1 by 1 plus sin x into 1 minus sin x by 1 minus sin x dx. So it is nothing but pi by 2 integral 0 to pi 1 minus sin x by, it is 1 minus sin square x dx. Okay children, yeah, so therefore it is pi by 2 integral 0 to pi 1 minus sin square x is nothing but cos square x. So 1 minus sin x by cos square x dx. So therefore pi by 2 integral 0 to pi, it is 1 by cos square is secant square x minus sin by cos square means sin by cos, and 1 by cos, it is nothing but secant x into tan x dx. Okay, so now it is pi by 2. Now secant square x is nothing but tan x minus secant x tan x is secant x. Now the limit is 0 to pi. You can apply and get the answer now. So it is, so tan pi minus secant pi minus tan 0 minus secant 0. Now you can apply, it is pi by 2 into tan pi 0 minus secant pi is minus 1. Tan 0 0 minus secant 0 also 1. So therefore pi by 2 into, it is 1 plus 1. So your answer is 2 by 2 pi only. Okay children, so we get the answer for this as pi. Integral 0 to pi x by 1 plus sin x dx is nothing but pi itself. Hope you all understood what I taught in this video. You should suppose remember all the properties children while do the sums. So please take all the sums in the exercise you do on your own. Any doubt you have means please ask through WhatsApp. Thank you children.